All right, so far we have learned how to load the data, how to perform different kind of slicing or extracting a particular kind of data from the data frame, obviously. Now let's see how to deal with the null values, right? So for example, here we have a lot of null values. Let's deal with the null values in the mileage column. Okay, there are again multiple ways. One of the ways is, the easiest way is to just get rid of the null values, which means what? If in any particular column, for example, let's assume this value is null. Right now we have a value over here, but let's assume there is no value over here. So what will we do? Easiest way is to drop the whole row. Okay. What is the negative point? Negative point is, if we have a lot of null values, we will end up losing a lot of data, which means here, for example, we have 221 null values. For sure, we are going to miss these 221 rows. But if you have data like 8,000 plus rows, then you're going to easily miss, this much of data. That's not a big deal. But if you do not have a lot of data, then you don't, you cannot afford to lose this much of data. In that case, what to do, we'll see. But right now we have a lot of data, so we can afford to miss this data. So easiest way is to say data frame dot drop NA, right? Drop the values which are not available. And then if I just do this, for example, run it, it returns me a data frame where the values are overall dropped from the whole data frame. But we just want to do this with mileage column, right? So I'll say do it with only mileage column. Running it. So now it is returning me the column, mileage column, with the values that with the removed value. And here you see the length is 7909, right? So 221 values are removed overall. But if we do not mention any column, then what will happen? It will overall go out, and you see now the number of rows that, it has removed the null values from all the columns. And we have 7,906 rows available with us, right? So this is one way to drop the null values, easiest way if you have a lot of data. Now, the second thing is the con and the cure. The cure is, if you do not have a lot of data or you don't want to lose a lot of rows, for example, in the seed column, one more thing. If I check out for the missing values over here now, we still have missing values in mileage column. Why? Because we just dropped it and it returned us a clean data frame, but we did not store this data frame anywhere. Well, we don't want to store it anywhere. I want to make changes inside this data frame. What can I do? I can say in place equals to true. Now, if I run this line again, it will make changes inside this data. It will return nothing, but it will make changes inside this data frame. So now if I run it, see, it returned nothing. But now if I run this line, you see it says 0000, which means that it has made changes inside this data frame. The changes have been made in place. By default, it was false, right? Now we have clean data frame. We can export it or do whatever we want to do with it. But we want to learn other methods as well. So what I'm going to do is I'm going to load the data again. So let me run this line. In this line, we are loading the data, right? So we have loaded the data again, coming here, checking out if we have any number of missing values. Yes, we again have number of missing values. Why? Because we have loaded the data again. So now we have fresh data. Okay, let's talk about this seeds column. Okay, so what we can do is we can say data frame dot fill NA. Previously we were dropping the values, right? Now we don't want to drop the values. We want to fill up the values. Okay, filling with what? We have multiple ways to do that. Again, we want to do it with only seeds column. Okay, it's seeds. Okay, fill NA. One way is I can specifically mention any value. For example, 4. Fill all the missing values of seeds column with 4, right? And also I'll have to mention that in place is equals to true. That is one way that I can write any hard-coded value. But there's a good practice to replace the missing values with any of central tendency measure. Now, what is a central tendency measure? With either average, mean, median, or mod. Okay. Now, where to use mean, where to use median, where to use mod. So, for example, here, if I use mean in seeds column, then what will happen? Mean is always going to be a floating point value, a continuous value. So mean of this seeds column is obviously going to be something like, where's the seeds column? Okay, so mean is going to be something like 4.9 or 4.8, but we have never seen any car with these many seeds, right? Seeds are always going to be in whole numbers. So we have to go with either a median or mode. So what I will do is, by the way, how to do that? I'll say, okay, copy this. So here, if I'll say mean is equals to seeds dot mean, right? So this, I mean, in DataFrame, we have a method that is called mean. Let me show you over here, copy this, place it over here. Now, what is the mean? What is the average? So average is 5.4. I can replace it with average as well, but that is not a good central tendency measure to replace over there, right? So if I don't want to do it with mean, let's try to do it with mode. So what is the mod value? Not mode, mod. Mod, it is going to be 5.0. Yeah, that looks fine. We can also go with the median as well. So median is also 5.0. So let's go with the median value, right? So let me cut this. Let's say MED is equals to this. Oh, sorry. Where is my other line? Yeah, here it is. So let me replace the upper line. MED is equals to data frame of seeds. And here I'm going to say equals to, no, not equals to, dot median, right? So it will get me median in MED variable. So I'll write MED over here. Now the missing values in seed column will be replaced with the median. Again, I repeat, we can replace it with mean as well. But right now, mean does not seem to be a good central tendency measure, right? So running it. And now, since in place was true, so it has made changes inside this data set. So if we come over here, we run it again, you see, seeds column does not has any missing value anymore, right? Now, seed column was a numerical column, right? But it was a floating point column, if you remember. But what if we have to deal with the values that are non-numerical? For example, right now, mileage column is non-numerical. So if I come over here, where is the mileage column? So here we see mileage column is non-numerical, right? So what if we have missing values over here in this column? What to do with that? First of all, I can literally see this column can be converted into numerical column. How? You can see KMPL all the time over here, right? So if we remove this KMPL over here, kilometer per liter from here, and in the column name, we say mileage kilometer per liter. So it will give me it will give us an information that the mileage is noted in kilometer per liter year, right? And then the only thing which will be left over here is 21.79, 15.1, 20.45, and something like that, right? And then rest of the values are numerical values. And then we can convert this column into a numerical column. So this is one way. First of all, convert the column into a numerical column. And then you can replace the missing values over there with mean, median, or mod. Same goes out with the owner column. For example, second owner can be replaced with 2. First owner can be replaced with 1. Third owner can be replaced with 3, and so on and so forth. Transmission column, we have manual transmission, automatic transmission. I think we have only 2 transmissions over here. So we can, this thing is called one-hot encoding or label encoding, where we are going to encode manual. We are giving a code to manuals. Manual will be represented by 0. Automatic will be represented by 1. And yeah, it will be replaced over here, and this column will become a numerical column. So this is one way. Convert a non-numerical column into a numerical column first, and then we can do a lot of things over there. Now, what if there's such a column that can never be converted into a numerical column? In that case, we can check out which value is most frequently occurring, which string is most frequently occurring in that particular column, and that most frequent occurring string can be replaced can be added into the missing values over there, right? So in next video, we'll see how we can transform this mileage column, for example, or maybe this engine column, for example, into a numerical column. And we are not going to do that, by the way. We are going to ask ChatGPT to do that.